And we can provide it with a more complex selection query. Let's assume we still work on the employee, this relation. And we have a question, we want to find all the employees who are either from department 2 or they have salary which is less than 31K. And how can we do this query and represent it with the relational algebra? So we know that we are do the selection in the rows, right? We want to find some employee tuples or records in the employee table, which can meet our requirements. Therefore, we know we need to use the selection, right? And we can write down the selection as, right, as this sigma. And then we have some condition, right? Let me write down change this one. And we know we are working on the employee, this relation, right? And this C denotes some condition. Let me do the subscript first. We have sigma C employees, right? Then the problem will be how to design a condition, right? According to our requirements. We know we want to find all the employees who are either from the department 2, and we'll do the selection of the tuples based on the department ID, right? Or with salary less than 31K, right? We know we are working on the salary for the second condition, and they are connected by the OR as the connector, right? Then we can rewrite this query by changing the C to some concrete conditions, and we know they are connected by the OR, right? The first condition will be department number equals to 2, right? We can say it is DEPT ID equals to 2, right? Or the salary is less than 31K, right? It will be the condition we have for this question. So the first one will be a department ID equals to 2. And the second one will be salary less than 31K, and they're connected by the OR, right? So then we have two parts. And this is a query we can write by using selection to help us find all the tuples matching our requirements. This is a common way, but sometimes actually we may work on multiple relations at the same time. Therefore, normally I prefer to change this slightly. We can write down this one as employee. This is a relation name, right? Then we have this dot, employee dot department ID. In this way, we can highlight this department ID is from the employee, this table. This is a relation. We have employee, this is a relation name, followed by a dot, and then followed by some attribute names. In this way, we can specify which attribute from which table or relation we are mentioning. It will be very similar for the scenario here. We can also rewrite this condition as employee dot salary less than 31K, right? This is a query we can write, and by executing the query on this relation table, we can get a new table. Remember, this selection operation, you don't do any changes to the schema, right? So therefore, the schema of the result will remain the same as the input. It will still cover 4 attributes: SSN, name, department ID, and salary. The schema is the same. However, the tuples or data records we have in the table will be slightly different because we are doing selection. Only a subset of instances will be added into the output relation, right? And here we can provide the result we can achieve by executing this query on the input employee this table as shown here. So the schema is the same, is still the same. And for the data tuples, we have 2 tuples instead. And we can check one by one. For the first one, it's about NX. NX, the department ID is 1. However, his salary is less than 31K, right? In other words, this row is valid, it is legal. And then we have another record is about Chris. Chris, his department ID is 2, even though his salary is larger than 31K, right? Since this condition for the department ID is valid, then this one should also be maintained in the output table. So by executing the query on this table, we can get the output table as shown on the right-hand side. right? I hope you can follow me about the selection operation. This selection is very useful for the queries we plan to write in the near future. And you will also use this very often for your project because you need to do some queries in the project to find some data tuples matching your requirements. So it can help you to operate your website on the database systems. This is about projection. Let's come back to the slides and then we can work on the next operation. It's called projection, which can work on the tables by selecting the columns instead. So in database systems, sometimes we may need to select some columns instead. In other words, we don't need to have the very big table. We only need to have that small size table with only a few number of columns instead. If so, we need to use projection to help us. So the projection is a unary operation. It returns certain columns. Formally, we can represent the projection as a pi with subscript a1 to an, and then we have parentheses, we have r, denotes the relation we are working on. So the pi denotes projection. A1 to an denotes the attributes we plan to get from this relation R. And R is the relation we're working on. Because we'll do this projection by selecting a certain number of columns. By reducing the columns, we may have some duplications created. So remember, in this operation, we will do this duplication elimination automatically. And let's assume we are working on a relation, the R. This R has B1 to Bm as the attributes. We plan to achieve a subset of attributes denoted by the A1 to AN, right? And we need to make sure this A1 to AN actually exists in the relation. Therefore, to work on this operation, we need to have a condition. The condition is A1 to AN is a subset of B1 to Bm. In other words, the attributes we plan to select, they exist in the relation. We cannot select some attributes which don't exist, right? So the A1 to AN should exist in the relation. It is a subset of the original attributes of the relation R. It's a condition. Because we'll do the selection of the attributes, we know that the schema will be changed because we only maintain a subset of the attributes in the output, right? So therefore, the schema of this operation in the output will be different. We can represent the output schema as S, A1 to AN as attributes. It will be different from the relation we have in the input, right? So this is about the projection operation. We can provide you with an example. Then let's assume we still work on the employee, this relation. We have the employee table as shown on the left-hand side. We have 3 data tuples. Here, we want to project the social security number as well as the names. In other words, we plan to get all the social security number and names of all the data records we have in the table. If so, we can represent this operation by its projection, this pi with SSN and name denoting the target attribute we plan to get as the subscript. So pi subscript SSN, comma, name, there are 2 attributes we plan to get, and we are working on the employee, this relation, right? So by executing this query on the input relation, we will get a new relation as shown on the right-hand side, right? We mentioned the schema is different because we now have 2 attributes in the output, SSN and name. They are the target attributes as we required, right? So the schema is changed, right? And we also check this SSN and name that both exist in the original relation. In other words, the condition is valid. And we can get the output as shown here. SSN, name, they are the attributes in the output table and the relation. And let's further check the data tuples we have in the output. Originally, we have 3 tuples. However, this operation, they don't do selection by the rows, right? In other words, all the tuples we have will be maintained in the output relation. We still have 3 tuples in the output table: Alex, Bob, and Chris. We extract the SSN and name in the output table. Right. Okay, so this is about projection. Projection want to get a certain number of columns from the input relation. In this way, if we have more complex queries following this operation, we don't need to work on this larger table anymore. We can directly work on this small size table instead. It can help us shrink the time cost as well as space cost for very complex queries. Right? So this is about projection, another example we can provide. And maybe I can provide you with another example, because we mentioned this operation will do the duplication elimination automatically. Sometimes if we do the projection by shrinking the attributes, we may have some duplications.